Alright, well, we're going to start the rest of lesson 3.3. We are still working with using a ratio table. Just to give you guys an update, what we should be doing is next class, we're going to do something that reviews the lessons, which is Desmos. It's going to be an online activity. It will be using your information that you know about ratios, tape diagrams, and ratio tables. You will also have a grade for it for ISTE, your technology grade that you'll see on your report card. And this is kind of like where we're gathering information where you're at for your benchmark. So we'll be able to grade you on that, and then you also get a completion grade. And then we'll move on to lesson 4. Should take a day. We'll go to lesson 5. After lesson 4, we'll do 1 day to review, and then we're going to take a quiz. Now you guys know how important quizzes are, and because they really affect your grade a lot. So make sure if you're anything confused with ratios, tape diagrams, ratio tables, when we go to do our review, I'm going to show you about those videos that you can be watching to help you when you study. I'll make sure to give you the study guide that we'll do in class. And then remember, I give you that practice test. The importance of the practice test is shows you what you would do on the quiz. Alright, so let's finish up today. This was your only homework assignment, and to be honest, I'm not even checking it, was to finish these 2 tables. Now, we're going to learn something else. I'm going to add something into our notes before we go to it. So will you guys turn back to the page that said example 1. Alright, when we do example 1, or not example 1, but what I'm going to put over here in example 1 goes to everything. And I'm going to say methods, I just put it on the side. Methods to solve. Now, remember I told you guys that some of you are probably loving completing ratio tables because it's like problem solving. It's like a game. Some of you aren't liking it because you don't have just one set of rules. So what I'm trying to do is I'm going to show you different methods you can use to solve. And you have to find out which ones work best for you. But it kind of gives you a little go point. So you're not just looking at the table and you're like, I have no idea what to do. Alright? Shay, I need you to take your headphones off so I know you're listening to me. Alright, so here we go. The very first method is method 1. And we're going to say add or subtract. This is the important part. By the ratio. So the most important part is if I'm completing a table, we have to add or we have to subtract by the ratio. I don't look at this one right here, triangle to the side, and say, hey, I added 1, so I'm going to add 1 to the sides. And you can't just say over here, hey, frogs, toads, 4 to 20. Okay, I added 16, so 6 plus 16 is 22. That doesn't work. And the reason is ratios are like fractions. It's all about a proportion. And if you just add to it, think about a fraction. Could I just add 1 to a fraction and get 2/3? Well, if I do this, is 1/2 plus 1 more slice. So I had a pizza. I ate 1/2, and then I'm saying I ate another half. Or I ate another 1 slice. But when I did 1/1, is that 2/3? No. When we add to ratios or fractions, we can't just add the same number because it doesn't keep it in proportion. So, the only way we can add is if we use the ratio. Now, I'm going to use this one. If it was 1/3, that means if I add 1 to the top row, we add 3 on the bottom row. If I subtract 1 on the top row, I subtract 3 on the bottom row. Does that make sense? Just like we did here with triangle to the sides. My ratio is 1/3. I added 1, So I added 3. You have to add what your ratio is. Okay? And the reason you can do that is because it's just like repeated addition. You're mainly using multiplication. You're just not showing the multiplication. You're doing repeated addition. Alright, method 2. Multiply or divide. The important part here is that you have to multiply or divide by the same number. This is the one that we do use that same number. Let's see if our buses are right. So, just like we did here with frogs, we did 4 times 5, so the other one we have to times by 5. Method, I'm going to draw a black line here. Method 3. Third way you could do this. Now, I don't want to mix these out of order, which I did. Oh, yeah. You can make it an input, output table. And you're going to have a rule. If I looked at this one, the triangles and sides, we pretended it was an input-output table. 1 triangle came in, so 3 sides came out. Okay, well, 1 times 3. You have to check that rule. Does it work multiple times? 2 goes in, 6 comes out. 3 goes in, 9 comes out. Every time my rule was times 3. Now the reason we're showing all these rules is because no one rule works every single time. Sometimes it's easier to use the other ones. Let's go with method 4. There's 5 of them we're going to use. If I don't forget it. Yeah. 4, I'm sorry. Draw a picture. And sometimes that's going to work the best is to just draw a picture. You're going to see we're going to do that today in example 3.
Hi.
How you doing today?
Good. I'm going to select Jack's computer.
Oh, that's fine.
Oh.
Alright, last one, method 5. Mixture / number sets. So when I say mixture, it means, hey, one time you might use addition, one time you might use multiplication or division, and then you also are going to use number sets. And that's what we're going to see today on the example, I think it's 2 or 4, you're going to see the number sets that you have to use. Alright, so I really want you guys to see these 5. I'm going to make a poster for all of them. We'll have them up there, okay? Alright, let's go do this and see what we used. So, on this triad, I'm going to erase my equivalent ratios. Here's what I would do. This is how I would set this problem up if I was you. I look at my table and say, hey, hands to people. And to be honest, right now I can use number sets. Method, what, 5 I just said? Number sets. Think about it. Here's Fernando. How many hands does he have? How many hands does Fernando have?
2.
A person has, and that's what it's saying. 4 hands, 2 people. Okay, Cohen, Fernando. 1, 2, 1, 2. Yeah, that makes sense, right? Sometimes you can think of the chart. Now, could a person have 1 hand? Yes, I know. We're not doing that argument. They're using this as a generalization. But would this make sense? I have 2 people, and I have 4 hands. Okay, well, what happens if I have 4 people? So here's my table group. 2, 4, 6, 8. It just makes sense that my answer would have to be 8. What if I had 12 hands? Okay, well I have 2, 4, 6, 8, 10, 12. How many people did that take? If I had 16 hands, I need how many people? Okay, we just solved that one. And if you did this on your homework, I'd like you to, if you fill that out and you're really just using number sense or a visual, I just write number sense down so I know what you did for your work. Okay? You said, hey, I didn't really do math. I used number sense. Or I used a visualization. I was able to look and go 2, 4, 6, 8, 10, 12. 1, 2, 3, 4, 5, 6. Oh, I need 6. That's completely okay. However, could I have used any of the other methods? Absolutely. Here's what I would do. I'm going to erase this real quick. Caleb, I need you to listen because this is the stuff that you're going to use. I'm going to erase this real quick because I want to show another situation. Now, what I would do is I'd look at my table and I'm going to say, hey, I don't know what this one is. However, do I know its corresponding ratio? Yeah, it's 4. So now I can ask myself all those questions. I can say, 1, can I add by my ratio? 2, is there an input-output? 3, can I just do multiplication? And to be honest with you, for me, personally, I use the multiplying and dividing the majority of the time. And this is what I would look at. I don't know this one, but I know the corresponding angle is 4. I look at the same row. I have 2, and this is the key. If I go to 2, make sure that we know its corresponding ratio. So I know both of them. How do I go from 2 to 4? We could times by 2. So I do 4, the corresponding 1. I have to do the same thing. 4 times 2 is 8, which is what we already found, right? I'm just proving this. Okay, so now I'm going to go here. It doesn't matter. I can do either blank. Let's say I did this one. I do not know this ratio, but I know its corresponding partner, 16. Can anyone tell me a way I went from 4 or 8 to 16? Why did I not say 12, by the way? Why did I not use 12 to 16? Caleb? No. Tristan? Well, I'm not even checking if I can multiply 12 times anything. Why did I not want to use 12, even if it worked?
Because 8 times 2 is, or 8.
Nope, before I do any of that math. Why did I know I don't want to even check to see how did I go from 12 to 16? Do I know its corresponding ratio? So if I don't know its ratio, even if I found out how to go from 12 to 16, can I go from blank to blank? No, I'd be missing a number. So I can only use the ones that we know both ratios. All right, so who wants to tell me, which number do you want to go from? Do you want to go from 4 to 16 or 8 to 16? 8. Sure. How did I go from 8 to 16? Times by 2? So I have to go 8's corresponding is 4. And that goes to the corresponding angle ratio of 16. So I times by 2. 4 times 2 is 8. Okay, not bad. We go to our other missing blank. I don't know this one, but I know 12. Now, can anyone tell me, how did I get from 4 to 12, 8 to 12, or 16 to 12? Tristan?
4 to 12 would be times 3.
Okay, so if we go from this ratio to this one, we times 3. So 2 to the missing corresponding is times 3. 2 times 3 is
6.
And there's my measurements. Now, could I have used addition subtraction? Remember, our ratio was 4 over 2. I could have went 8 plus that ratio of 4 is 12. So then 4 plus the bottom corresponding ratio 2 is 6. 16 minus 4 was 12. So 8 minus 2 is 6. Alright. Let's check what you guys did on number 2. What were your answers? So, miles and hours. If I go 4 miles, it took 3 hours. What were one of the blanks? Tristan?
Do I have to give any blank or do I have to give the first?
Sure. Any of them.
72.
Huh?
72.
To which one?
96.
Anyone else have an answer? Joseph?
Wait, yeah, 18.
Where's 18 go? Under 24?
Yeah.
Okay. Avery? 8. Alright. Now let's see if we got these right. For me, I would have said, hey, I don't know this one, but it's corresponding number 6. 3 to 6, I'd say I'd times by 2. So 4 times 2 is 8. Avery nailed it. I would have said I don't know this one, but its corresponding angle is 24. And I would say, I can do 8 times 3 is 24. So 6 times 3 is 24, or is 18. And then we had this blank. I didn't know it, but its corresponding was 96. Oh, woo! Which one do you want to use? 4, 8, or 24? You can use 24. 24 times 4. So 18 times 4. Make sure we get that right. Is 72. Yes.
I also did it because I saw 43. There's 1 less, and then if you multiply that by 2, there's 2 less than
And that's using what you're doing right there, Tristan, is totally fine. You're using some multiplication, but you're also using number sense. You're understanding the first time I have the ratio, I'm 1 away. So the second time I'll be 2 away. The third time I'm going to be 3 away, and so on. All right. Let's look at example 2. Completing ratio tables. This is exactly what we just did. Adding and subtracting, multiplying, dividing. To be honest, the first examples, they didn't want us mixing it up, but we're going to now. So, we're going to do... Get away. Okay, we're going to do this together. Even though the notes are right here. The answers are right here. You can use these, or let's find another method just so we can practice it. Dollars to cents. To be honest, what would I probably use? Can you think of what method would probably be the easiest? We could use multiplication. Could add. Maybe multiply and dividing. Huh? I'd probably use number sense. Guys, it says $1 equals 100 cents. Well, how many cents are in a dollar? 100. So we should be able to roll through this pretty quick without doing much. So if I had 300 cents, how many dollars do I have? I had $3. If I grabbed Fernando and I shook him, Fernando, I'm so going to move you next time you're going to sit like in the back over there so I don't have to pick on you anymore. If I grab him by the ankle and I shake him upside down for his milk money and 900 cents comes out of his pockets, how much is 900 cents? And then I drop kick Jack, and I take $8 of his, and I go to the video arcade over at, we'll go to Minsky's, so I'm going to play those arcades, and I take his $8 and I put it into the machines to give me change. How much change would I end up getting?
800 cents.
We get 800 cents. Now, do you guys see how we really just use number sense there? Did we do any of this multiplication? No. We kind of did the input-output rule, but we just used it because we knew it. We knew $1 is 100 cents, so 300 divided by 100 is 3. But do you see how all my work, if you did this way, I would say number sense. and cents, because that was on the example. Yeah, trick order's fine. Alright, so let's try B. Let's do this method. I do not know this blank, but I do know this one. This is going to get really tricky here in a second, so pay close attention. Now, do I want to use a fraction 5/3 to 2 or 1 to 2? Why? Not just because it's easier. Why do I have to use the 1? Tristan? Maybe. What's up? A bandit? Yeah. I got 82.
Hey, you guys decide fun. You guys like board design. You know what is cardboard.
Ooh, those are nasty.
Oh yeah, cardboard.
Remember, not just because 1 was the starting one, but because we don't know the corresponding ratio for 5/3. Alright, so, I'm going to pick on someone. Who do I want to pick on? Grace. I haven't heard from you this morning. From 1 to 2, how did I get there? Okay, so if I added 1, yeah, everyone listen to this. Shay, I hope you're following along. Grace said I'm going to add 1. If I'm going to add, remember I have to add by my ratio. What is my ratio? 3 to 1. Okay, can I add 1? Yeah, that's on the bottom. So if I add 1, that gives me 2. Raise your hand. You can tell me, what do I have to add to the 3? Caleb? Nope. We just said that. We can't add. We add. We do not use the same number. Siri? We add the 3. The top ratio. You add the bottom to the bottom row. We add the top to the top. We get 6. Perfect. Alright. I do not know this ratio. What? We added. Oh, okay. We do not know this one, but we know the corresponding one is 2. Well, how did I go from either 3 to 2 or 6 to 2? Joseph? Which one? Did you go 3 to 2 or 6 to 2? Yeah. If I know my math facts, oops, I forgot right there, I added 3. I divided by 3. So 2 divided by 3 is, we can write it as a fraction. You are going to be writing fractions. Okay? So we get 2/3. Now, here comes the tricky part that you guys are going to earn a piece of candy on, maybe. I do not know this blank, but its corresponding blank is 5/3. I'm going to already give you part of the answer. The textbook told me that I added 1, which is right here. I added that denominator. I did 2/3 plus 1 whole, and I got 5/3. Now, hold on, we're going to come back to it. Because I added the bottom ratio, I have to add the top ratio. So 2 plus 3 is 5. Now that's our answer. Here's what I want you to do. Raise your hand. Can anyone tell me, don't shout it out, raise your hand. Why did I do 2/3 plus 1? How does 2/3 plus 1 is 5/3? Do you know? Raise your hand if you can tell me. Okay, hands down. Raise your hand if you do not know right now. Alright, here's the test. I'm going to pause for about 30 to 60 seconds. I have 2 things of nerds, because if you can get this, you're nerdy like me. I'm only calling on one of the people that raise their hand that do not know how to do it. So if you did not know how to do it, and you can tell me the answer, I'll give you a box of nerds. But here's the extra kicker. Whoever teaches it to you also gets a box of nerds. So if you're a person that knows how to get the answer, you go find someone that does not understand it. You have to explain it to them so they understand it. And then if I choose them, they have to be able to explain it. Ready? Go! Alright, back to your seats. Let's see. Who did not know it, but now can? Who did not know it, but now they can explain it?
Oh, I got picky for now. So technically, no.
Did you not know it before? Who helped you? Go on. Alright, let's see how you did. Why is 2/3 plus 1 5/3?
Did I forget already?
That's okay. We'll get to it. Z?
Because you add them and then it's 1 2/3.
Okay. So I could say 2/3 plus 1 whole is 1 2/3.
And then you added 5 1 whole. Well, you don't add that 5 1 whole,
Close. But not quite all of it yet. Trevor?
6. No 5/3. That is, it's above 3, so you would only have 1. And 5 minus 3 equals 2/3. So if you add that equals 1 2/3.
So you changed 5/3 to 1 whole. And then 5 minus 3, I'd have 2 left over. So you're saying 1 2/3. Okay. I don't think I'm going to take that fully yet, though. Because that proves that this is right. But that doesn't... I couldn't have used that method when I didn't know what this answer is. If I just said 2/3 plus 1, I would have known that's 5/3. How do I know that it's 5/3? Who else didn't know it? Did you not know it before? Alright.
I think so. If you 1 is equal to 3/3.
There we go. Alright, so 2/3, when you add fractions, you have to add fractions with the same denominator. 1 whole is the same as 3 out of 3. Remember, that's same numerator, same denominator. 12/12 is 1. 57/57 is 1. So 3/3, 57/57, they equal the same amount. Just 1, even though they're different digits. If I had 57 pieces to a pizza and I ate 57 slices of it, I ate 1 whole pizza. If I cut it into 3 slices, my slices are bigger, but I have some less of them. So 2/3 plus 3/3, denominator stays the same. You add your numerator. Alright, so Joseph, who told it to you? Avery? Alright. Okay, let's go to this triad. I'm going to call on, you guys do not have to stay in your table groups today. You may quickly work with anyone around the room, and I'm going to give piece of candy to 2 people that work on this together and get all the answers right. 1 person tells me the answers, 1 explains it. Ready? Go. Alright, so number 3, which power group has the answer? They can tell it to me, and then 1 person can explain it. Cohen, who's your partner? Alright, so 1 of you gets to tell me the answers, the other one has to explain how they got it. Alright, Caleb, what did you get?
Okay. Under 2 is 10. Under 4 is 20. And above 15 is 3.
Okay. Now, Cohen, for the explanation, how did you find your answers?
1 times 5 is 5, and 2 times 5 is 10.
So you made this.
5 are divided by 5.
Alright, so if you guys don't understand what they have there, without even knowing what they're doing, if that's the case, they did it right. They made an input-output table, and they said the rule was times 5. 1 went in, 5 came out. 2, and they could just do this to show work. They say times 5. 4 times 5. And then this one, if you didn't know, you could, it depends how you guys like to do your math. You could say blank times 5 is 15. Okay, well, 3 times 5 is 15. Or, I like how Cohen said the rule could be divided by if you went backwards. You could go bottom to top and divide by 5. Alright, perfect. Split with him. There's 2 in there. Now, this is also, I just want to point out, this is one of the main ones that I could have drawn a picture. So if you really struggle with this, you could have said, hey, here's one flower, and it has 5 petals. 1, 2, 3, 4, 5. And then you would have said, hey, I have 2 flowers. Oh, yeah, I'm going to label. 1, 2, 3, 4, 5. And then it said, I have 2 flowers. So 1, I'm not going to color it this time. 2, 3, 4, 5. Or 4, 5. So I had 5 petals, 6, 7, 8, 9, 10. Okay, 2 flowers is 10 petals. 4 flowers. Oh, 1, 2, 3, 4, 5. Okay, 11, 12, 13, 14, 15. I need 4 flowers. 1, 2, 3, 4, 5. 16, 17, 18, 19, 20. 4 flowers is 20 petals. Blank is 15. Oh, wait, look, I have 15. It's right there. 1, 2, 3 flowers. This is one that you could draw a picture. Now, do I probably want to draw a picture on the students and teachers? I can. But I see right away one of my numbers is 36, and yeah, I'm not going 36 or something. Alright. Let's see. Who can else tell me the answer? Who? Alright. Tristan, you were with Joseph?
Yeah, I'll do the answer.
Alright, Joseph, what are the answers?
12 is 1, and then above the 4 is 48, and under the 36 is 3.
Alright, so Tristan, what were the rules? How'd you do this?
I did input output,
Okay.
and the rule is divide by 12.
So they did input output. Students to teachers divide by 12. So I would show 24. I guess you don't have to do it that way. 12 divided by 12 is 1. This one though, if it's blank divided by 12 is 4. Remember, you could go the opposite way. 4 times 12, 48. 36 divided by 12, 3. You guys will see a lot of times input-output tables are really awesome. They make it easy. If you see you have input-output tables, you like to use it. Alright. This is one where you will use number sense. Now, the notes are already here. So please just follow along with me. I'm going to show the... Oh, this big idea is running. We'll have to see.
What did we get?
We had a problem. We have to talk about it. Alright, example 3. Oh, we're back up and going. Alright.
A nutrition label shows that there are 75 milligrams of sodium in every 12 crackers. You eat 30 crackers. How much sodium do you consume? Method 1. Use the double number line. Increment the number lines using the original ratio of 75 to 12. Add 75 to 75 and 12 to 12 to get the ratio 150 to 24. add 75 to 150 and 12 to 24 to obtain the ratio 225 to 36. Notice that 30 is halfway between 24 and 36. So find the value halfway between 150 and 225. 187 and 5/10 is halfway between these two numbers. So you consume 187 and 5/10 milligrams of sodium in 30 crackers.
Let's point something out here. If we looked at this, they also showed it with an input-output table, or a table. But one way you could use this, just like they said, there's a double number line. Here's my heads up for you guys. And this is my disclaimer. This is where it can get hard. And you have to use number sense. If I'm not good with my math facts yet, this can become tricky. That's why I really stress you guys practice your flashcards. Because that makes all math easier. When I look at this, and I was going from 12 to 30. Well, if I would have drawn this, I would have thought, here's 12, and then here's 30. And we would have looked at this and said, oh wait, there's 75 here. And I'm trying to find this blank. Is there an input-output from 75 to 12? Now, there is if I go to a decimal, but for most of us, we don't do that. So it's not easy. So I go, okay, no. Even if I look at our 5 methods. Method 1, could I add and subtract the ratio? Okay, can I add and subtract anything? Can I do 12 plus 12 plus 12 to get to 30?
No.
12 plus 12 is 24, plus 24 is 36. Okay, I can't add. Method 2, we said was, what, multiplying and dividing? 12 times anything equal 30? No, so I can't multiply. Input-output table. 75 to 12? No. Draw a picture? Well, but 12 doesn't go into 30, so no. I'm mainly left with I have to use number sense. I have to figure out what can I do to 12 and how can I change this? And some of you, you're going to work harder than other people. And the reason is you don't know your math facts. This is where I always say it's crazy is the people that had worked hard before and know their math facts, they tend to have to work less than people do now. Because I know my math facts, and I would have said 12 and 30. Common factors. What goes into 12 that also goes into 30? 6. Oh. Well, if 6 is a common factor, I'm going to go to 6. How did it? Because I can say, hey, I'm going to go from here to 6, and then here to here. That's going to be my stepping stone, because I knew a common factor. So 12 divided by 2. So I could say 75 divided by 2 is 37.5. Even though it's a decimal, it's okay. And then 6 to 30 was timesing by 5. So I times this by 5, and I get 187.5. Now, if I didn't know my facts very well, I might have just started randomly trying things and going, okay, I'm going to divide by 4 and get 3. Ooh, I could have done that. I could have divided each one by 4 and got 3, but then I would have had, I don't even know if this comes out right, to be honest with you. 75 divided by 4. Oh, I could have. If I would have divided by 4, I would have had 75 over 12. Just showing you why this would have worked. So if I would have divided by 4, I would have got 3 divided by 4. What did it say? 18.75? Is that what it was? Yeah. Okay, how do I get from 3 to 30?
and 187.5.
I could have tried, 12 times 2 is 24. And see, there's lots of ways. I mean, I could make this a contest where, maybe I'll do this for fun. Like, I give you a ratio table and you have to bring up another way. And every time you come up with a new method, we give you points. That'd be kind of cool. Because I could have used, not to totally confuse you, but I could have, just for fun, I want to do this now, because now I'm being nerdy. This is where number sense really comes into play. And this is where you can solve this in multiple ways. Come on. Look how big that is now. Alright, if I had 12 here, 75 here, what if I would have, remember my goal was to get to 30. What if I would have times by 2? That'd give me 24. Times by 2 would give me 150. But then what if I would have done 12 divided by 2? That'd give me 6. If I divided by 2, 37.5. And then I could have said, hey, 24 plus 6 is 30. So 150 plus 137.5 is... So there's all these different ways. My biggest purpose on showing you these is not trying to confuse you. You are getting confused, I know. But it's calm down. Don't look at something on here and say, there's one answer, or there is one answer, but there's one way I have to solve it. I don't know how to solve it. Start trying. Just randomly try something. Try multiplying. Look, how did I go from one number to the other and just try it? Okay? Alright. We're skipping to our last one. Why do I put the self-assessment on your notes? So, say that again.
Try it out.
So you have to try this?
No.
Now, remember, this is it for extra review if you're wanting. If you do this on blank piece of paper and you bring it up to me, I give you a link spot. Okay, last one, number 4. We are going to watch the video, but I want everyone to vote now before we even answer. You'll see on the bottom of your notes, it looks like this, so it's not filled out. You're going to fill your notes out with me. This is a tricky story problem, but let's read the problem, then I want you to make an educated guess. You and your teacher. So, who's going to be making cupcakes with me?
Teacher.
Alright, Andrew.
Oh, buddy.
Alright, Andrew and his teacher made colored frosting. Andrew added 3 drops of red for every 1 drop of blue. Now, when we mix a color with the red, it takes a little bit of the red away, right? Everyone understands? So, Andrew has a ratio of 3 red for every 1 blue. Your teacher, I did this last time, Sizzler, and then watch this. Exclamation point tonight, Sizzler. Sizzler, I did 5 drops of red for every 3 drops of blue. So when I took my frosting, I went, where Andrew was like, he wasn't into it. Like, I was excited to make cupcakes with him. Now, here's my question. The rest of the story, I guess I should read the rest of the story. Whose frosting's red? Okay, so here's the question. Without doing any math yet, I just want your initial feelings. If Andrew put 3 drops of red and 1 drop of blue, and then I put 5 drops of red and 3 drops of blue, and then we mix them, who do you think is going to have more red? Who's going to have more colored red? So, here's what we're going to do. If you think it's Andrew, I want you to stand up tall and stretch. If you think it's Sizzler, you need to lay on the ground. 1, 2, 3. I got a couple on the ground. Oops, keep doing it so I can count. Whatever, I'm pretty sure, Kelly, you were just laying on the ground because you're like, I'm just going to lay down and take a nap real quick. Alright. Okay, everyone back. Let's see what we can do. Follow along in your notes and fill in the notes as they do this. And we'll be done.
Wait.
Do not know what's going on right now.
I do.
Waiting. 'Cause I'm waiting.
Wait. Mr. Cecil?
Huh? Tristan,
Can I tell you something?
can I respond to you?
Sure.
Oh, not now.
You and your teacher make colored frosting. You add 3 drops of red food coloring for every 1 drop of blue food coloring. Your teacher adds 5 drops of red for every 3 drops of blue. Whose frosting is redder? Use a problem-solving plan to solve. First, understand the problem. What do you know? You are given the numbers of drops of food coloring that you and your teacher used to make frosting. You are asked to determine whose frosting is redder. Next, make a plan. Use ratio tables to compare the frostings. Find ratios in which the number of drops of red, the number of drops of blue, or the total number of drops is the same. Then compare the quantities to determine which is redder. Then solve and check. Look back at the ratios in the problem. You add 3 drops of red for every 1 drop of blue. Your teacher adds 5 drops of red for every 3 drops of blue. Create ratio tables for these ratios, 3 to 1 and 5 to 3, using repeated addition. Include a column for the total number of drops in each frosting. Now you're ready to solve. Create the ratio tables for your frosting and your teacher's frosting. The ratio of drops of red to blue for your frosting is 3 to 1, and for your teacher is 5 to 3. Start with your frosting. Use repeated addition with the original ratio 3 to 1 to create the table.
Now, if we're using addition, like she said, remember, we're going to add with our ratio. So, 3 drops of red, 1 drop of blue. So every time I looked at Andrew, he'd take his color and go, 1, 2, 3 red, 1 blue. And I'd look away, and then I look back and go, 1, 2, 3 red, 1 blue. Just like a little weirdo. I don't know what he was doing. He was just being kind of goofy. He had that look in his eye. Like that one right now. Like, everyone looked at him. That was awesome. They're like, oh, my luck. Just totally making this up, guys. We really did do this. Alright, so if I added 3, how many is going to be in the red?
6,
And then,
9,
and then,
12,
and then,
15,
and then for blue, 1.
2, 3, 4, 5,
Now they say total drops. So then I do 3 plus 1 is.
4.
Okay, we're going to do the same thing for the teacher. Okay? I'm actually going to get out of this video because I don't want to give too much of an answer. So let's do this together. Alright. So for Andrew's frosting. So drops of red, we said 3, 6, 9, 12, 15. Blue, 1, 2, 3, 4, 5. And then we'll mix the two. Oh, I should have like a purple. Do I have a purple? Ooh, it's like purplish red. Great color. 4, 8, 12, 16, 20. Alright. Everyone okay how we made his ratio table? We're going to make mine, and then we have to learn on how we compare them. What was my ratio? Siri? 5 to 3. So 5, 10, 15, 20, 25. Please do not, if you ever figure out this answer, don't shout out. This is a tricky one, and we want people to think. 3, 6, 9, 12, 15. Total. We need to do that. Where are these other ones? Up. Okay.
total would be 8, 16, 24, 32, 40.
Alright. So that was pretty easy. Now comes your common sense, your math sense. If I'm comparing Andrew, and not the teacher, Shijo.
Get your cross out, teacher.
Graffiti. Okay. How can I find my answer? Now, to be honest, I have 3 gobstoppers with 3 gobstoppers in each package. So I have 9 gobstoppers. But you get 1 package. There's 3 ways to identify your answer based off the table. You have to do no more math. Okay? There's no multiplying you have to do. There's no dividing. There's no adding or subtracting. All I need you to do is read your graph. There's 3 different ways you can find out whose has more red. So everyone look at these. So I'm going to have one person answer, and if they do it right, I'm going to pause for another 30 seconds and see if you can use what they said to figure out how to do the next one. Alright, so Shay,
What's one way you think you can figure out who has more red?
By seeing the difference between the red drops and the blue drops.
What do you mean?
Taking 5 and subtracting.
nope, I said there's no adding or subtracting doing it. All I'm doing is reading my graphs now. Caleb, what is?
The answer, because he said if you take out one of the red, then it's going to take out some of the. You add blue, it's going to take out some of the red. 25 minus 15.
Oh, nope, we're not subtracting anything. Zeta?
You look at the difference between Andrew and Sizzler's drops of red at the bottom.
Oh, 15 and 25? Nope, because I can continue this chart. I can keep going. Joseph?
You look at the number of total drops.
Okay, what about him?
Well, 4 and 8 will share the common factors too. And so then you can compare if you times the.
Well, I don't have to times because there's 8 right here.
You can compare those 2 together.
Alright.
How can I compare 8 drops of Andrews to 8 drops of Sizzler?
You could look at the number of red drops.
Okay, so who had more red?
And
We compare how many total drops we did. And there's another one right here, it's 16.
I don't want someone to think that's the other one.
When Andrew put 8 drops in, he used 6 red. When I did 8 drops, same amount of drops, I only had 5 red. So whose is going to have more red to it? No matter what the blue is, we know the blue has to be less, but we had the same amount of drops. Boop, 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 boop. He had more red in his than I did. So he will have more red. Okay, what's a second thing you could read off the chart?
If you didn't want to look at total drops.
Andrew?
Could you do the drops of blue?
Okay, what do you mean? Tell me more.
I think that kind of takes away from the red.
Okay, so what am I going to compare though?
Sure, like with the 8. When you did 8, I had.
Nope, we already did total drops. No more total drops. If I'm looking at drops of blue, what could I be looking at? Tristan?
So Andrews, he has 3, the third one down on the chart, and you've already used 3 drops of blue on your first thing on your chart.
close, but no. Siri?
Whoever is doing the least amount of blue is gonna make the frost redder, so then it just be Andrew because it has more red and blue.
Good. So, if right now, if we put the same amount of blue, guys remember, if I put 5 drops of red and 3 drops of blue and I mix it, it'll make a purple color, right? If I did 25 drops of red and 15 drops of blue, it's going to be the same shade of purple. The purple color is not going to change. The only thing, it might be brighter or more like deep, but it's the same shade of purple. Okay? Now, what Siri just said is, well, if I put 3 in and he put 3 blue in, blue's going to take away from the red. So whoever has the more red, it's going to take away the least amount. He had 9 drops to his 3, where I only had 5 to 3. So my 3 drops are going to take away more of my red drops than Andrew. So Andrew's is more red. Okay, take 30 seconds before I call on the next person. There's one other thing we could have compared. Avery?
For the drops of red, you have a 15 and Andrew's 15.
Okay, so how do I know who has more red then?
Because when your drops of red, you used 15 with 9, and you used 15 with 5, so there was less blue, so you have more red.
When we both put 15 drops of red in, we just did that. We both put 15 reds and we mixed up. Our frostings will be the same amount of red. Every drop of blue we put in takes a little less of red. We both had put in 5. He put 5 in, and I put 5 in. They'd be the same amount, but then I went bloop, 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 and put 4 more blue in. So mine would be less red. Once again, Andrew wins. Alright. 2 things. I'm about to give you homework, and I made the same rule, and actually it looks like it's working because I'm still having a little bit of trouble with big ideas. Like it's working, but sometimes it's not. I have assigned the homework to you guys. Now, I assigned it last week. Some of you may have worked on it. So if you look at your assignment today, you have 2 things. You may either go on to Big Ideas and do lesson 3.3 homework A or B, depends which one I assigned you. If you already completed that before today, you're done. You have no homework. You're done for the day. If you have not, you have to finish it. You must show work. Your work should look like something like this. You have to show me, how did I get the missing numbers? Something like this. Or something like this. I have to be able to see how you got your missing values. That's what you have to turn in. Now, your options are, you may go ahead and you can go to Big Ideas right now and use the last 15 minutes of class so I can help you. You can work on Big Ideas there. If you do not want to do that Big Ideas, or if Big Ideas is messing up, I give you a worksheet. If you got the one that says lesson 3.3, I said practice on this side. Okay, it says reteach. The one side that says page 103, there's nothing for you to do. The answers are there. This side is mainly, if you're confused, you can look at this for help and notes. If you flip it over, there are 6 questions to do. So technically, which one do you have to do more of? Less of? Big Ideas or this worksheet? Well, worksheet, really you have to do 6 compared to 10 there. But online, you can check your answers. The worksheet, you cannot. What we will do next class is you have to have one of the 2. I'm going to look online, see who did Big Ideas. I'll put down their grades. If you do the worksheet, we're going to grade it together in class. You'll put your pencils away. I'll give out red pencils. I'm going to give the answers, and you have to check them. and you didn't get to check your answers. So you can either do 1 through 6 or big ideas. Huh? He gets to show work. Yep. So, Joseph just asked, do I have to show my work on paper? Yes. So, like, if this is part of your homework, I want to see you go on your paper and say, oops. I want to see you say number 3. You can abbreviate, I don't care. You can say burgers, hot dogs, 3, 5, blank, 9. But you have to show me, what did you do? I went from 5 to 10, like times 2. So 3 times 2. Okay? You don't have to show me the work for the equivalent ratios, but for the table itself, you have to. Any questions?
Can I have you check my extra practice?